This is the world's largest digital camera. Astronomers will use it for exciting discoveries in the depths of the vast universe. Exploring the mysteries of the universe like never before is on the edge. The camera for the upcoming Vera Rubin Observatory is now finished. It boasts an incredible 3,200 megapixels. Each pixel measures just 10 microns in width. This massive camera, weighing about as much as a small car, will be installed in the Rubin Observatory in Chile. With its enormous 5-foot front lens, it can capture incredibly detailed images of large portions of the sky. It is designed for the Legacy Survey of Space and Time project. This 10-year initiative aims to photograph the southern sky and detect transient objects such as supernovae. With the camera complete and ready to join the Rubin Observatory in Chile, astronomers are poised to create the most remarkable movie of the cosmos and the most comprehensive map of the night sky ever seen. The camera's immense size gives it immense power, capturing a wide view of the sky and fine details. Its images are incredibly detailed, able to spot a golf ball from 25 kilometers away, covering an area 7 times wider than the full moon. With billions of stars and galaxies, these images will unveil the universe's mysteries. Scheduled to start its survey in 2025, the Rubin Observatory will push the boundaries of cosmic exploration for over 10 years. It's essential to look farther into the universe to understand fundamental physics better. The observatory will delve deep into the cosmos, tackling some of physics' toughest questions. Let's make some comparisons. Rubin is a ground-based telescope, while the James Webb Space Telescope is a space-based one. James Webb is focusing on deep space observations, the early universe, and exoplanet atmospheres. Capturing high-resolution infrared images, the telescope can see very faint and distant objects. On the contrary, Rubin will focus on wide-field surveys of the night sky. It will capture massive amounts of data over a wide area. Studying large-scale structures and changes over time will be possible. Let's make all of the information simpler. Think of James Webb as a powerful magnifying glass peering deep into the universe, while Rubin Observatory is like a wide-angle camera taking constant snapshots of the entire night sky. They provide complementary views that will help astronomers answer different questions about the cosmos. Astronomers eagerly expect using Rubin's camera to detect weak gravitational lensing. This occurs when massive galaxies bend space-time, amplifying light from distant galaxies. It helps study mass distribution and changes over time, crucial for understanding dark matter, which makes up 85% of the universe's mass. Scientists also aim to analyze galaxy distribution and changes over time to pinpoint dark matter clusters and supernovae. This helps enhance our grasp of both dark matter and dark energy. Within our solar system, astronomers will utilize the camera to better survey small objects like asteroids, planetoids, and near-Earth objects, which may pose collision risks in the future. It will also track the approximately dozen interstellar objects entering our solar system annually. Let's dive into other outstanding features of the camera. The focal plane consists of 201 specially designed CCD sensors, each customized for its purpose. Remarkably, its flatness deviates by no more than 1/10 of the width of a human hair. Taking all these things into account, here is a question. Why are dark matter and dark energy so important for astronomers? Because they are believed to make up the vast majority of the universe's mass and energy, even though we can't directly observe them. Dark matter is like an invisible scaffolding holding galaxies together. Astronomers observe galaxies spinning too fast to be explained by the gravity of the stars and gas we can see. Dark matter's gravity provides the extra force needed to keep them from flying apart. Understanding dark matter is essential for comprehending galaxy formation and evolution. Dark energy is a mysterious force accelerating the universe's expansion at an increasing rate. Imagine the universe like an expanding balloon. Normally, the balloon's expansion would slow down over time due to gravity, but dark energy seems to be pushing the universe to inflate even faster. Understanding dark energy is essential for figuring out the ultimate fate of the cosmos. In essence, dark matter and dark energy are key ingredients in the grand recipe of the universe. Without understanding them, astronomers can't fully explain how galaxies form and behave, or how the universe is evolving on a large scale. Can we solve the unknowns of dark matter and dark energy? Well, it is a challenging quest, but we might crack the code someday. Powerful telescopes like the James Webb Space Telescope and future missions are designed to peer deeper into the universe and gather more data. This could reveal subtle fingerprints of dark matter or dark energy's properties. Experiments at facilities like the Large Hadron Collider might create or detect new particles that could be dark matter candidates. New scientific theories could emerge that provide a fresh perspective on dark matter and dark energy, potentially leading to new ways to detect or understand them. Of course, there is no guaranteed timeline, but efforts by astronomers might lead to a breakthrough in the future. Keep hope alive.